All right, so we are now on day 4 of chapter 18. So we're actually going to be doing a little piece of today to help us with our lesson on Friday. So today we are actually focusing on the non-calculator portion of this lesson, and then tomorrow we will add the calculator part with it. And we are actually learning how to find a critical value, which we're going to call a z. It is a z-score, talking about how it compares to the mean based on the standard deviation. And we will be calculating probabilities, but that is not for today. Today I'm actually going to show you just how to read a chart. So we know that if we do any sort of simple random sample, we have an expected proportion of things to happen, which is that p-value, the probability of success. We expect a certain number. Now, we know that we aren't always going to have perfect answers. Sometimes we're a little above, sometimes we're a little below, but we just need to know how far is the range really supposed to be before it's like too far out. We always expect it to be within a certain range, so we know that, we always have this p-value, that probability of success, but sometimes we're above and sometimes we're below, but we're going to find out by how much. The standard deviation does come into play, but what we know to add and subtract, we're going to add or subtract that z-score times the standard deviation, which the standard deviation is p times q divided by n. We're still working with normal distributions. And so we will actually be looking at the z table today. So this is what we are going to focus on. We are only focusing on that z value. Now, the reason why we have to know that z value is because it is going to tell us a different confidence level. So we're going to have a certain confidence on our answers. We can say, I'm 95% confident that my answers are going to be between A and B, like a lower value and an upper value. I'm 90% confident. We definitely want a high level of confidence, because if you're not confident, no one is going to think that your data is valid. So we want a confidence level. If it's not given to you, we always like 95% confidence. So that is something that I want you guys to know. If a confidence level is not given, so if the confidence level is unknown, use 95% confidence. Say most of the time in statistics we can accept things that are at a 95% confidence level. We can't ever be 100% sure. 95% is pretty certain, 99% is super certain, but if you are given a confidence level, use that. But if you are given something else, then you will use the value that's given to you. But if you don't know it, use 95. So I want to explain how these z tables work. We are actually going to be using a z chart. So virtual students, you are going to have to print this out, and if you need me to print that out and have you come in and get it, that's totally okay. Doing this without a paper copy is going to be almost next to impossible. It's super difficult. So whenever you are looking at a z chart, we have z-scores going down the tenths, and then these are the hundredth spots. And so then, like if you want 1.72, you go to 1.7, this would be 1.70, this is 1.71, and then right here would be 1.72. Now I'll explain this. So for a confidence level, you have the mean, and it is a normal distribution, it's symmetric. So your confidence level then has a lower bound and an upper bound. So this is the lower bound and this is the upper bound. And then what is inside here, that is your what we call a confidence interval. Now, I don't know if you guys can see, here we have an upper and a lower. I don't know if you noticed on the chart, there's only an upper. It actually goes all the way down to 0. So we do have to do a little bit of adding and subtracting. Those little ends that we don't want, we actually call those tails. So we actually want the right tail and the left tail out of our level. The table does include the left tail, so we always have to subtract that out whenever we're doing the work. So the first thing I am going to do is I'm going to give you some examples of how to find a z-score given a confidence level. So that's our first examples. Finding the z, that critical value given the confidence level. All right, so the very first one I'm going to recommend is a 95% confidence level. So what we are trying to find out here, and I want you to know it's not just as simple as the chart is like finding 95 and getting an answer. We have to do a little bit of work. So if I want a 95% confidence interval on my table, I want the range of these numbers to be 95% of the data. Now, the entire curve has to add up to 100%. So if this is 95, the other two sides together have to help us make 100. So we know that 95 plus 5 is 100. And you can do this with every one of them. You don't have to use the calculator, obviously, if you can do this in your head. But we know the whole entire curve is 100%. Take out that confidence level. So that means that the two tails on the outside have to add to 5. So each half is 2.5%. So we have 2.5% on each end. And then if you can see here, our z-table, we want to know from this number all the way to the left, the upper bound to the left. So if I take the upper bound and shade everything to the left, I'm going to use the chart now to determine my z level. But I have to include this tail. So if I add 95 and 2.5, that's actually 97.5%. So, or a proportion of 0.975. This is what I want to find on the chart. So the percentages or the proportions are in the middle. And so what we want to do is we want to zoom in. And I hate doing that because then you can't see the edges, but you want to go and try to find the closest thing to 0.975 that you can. So it is in order. At the top, it's all the way up to 0.5, and then it goes all the way almost to 0.1 or 1, but we never have a perfect 1, so it actually stops at 0.998. But if we want to look at this chart, we want to try to find a perfect or as close to perfect 0.975. And if you can see, we actually have a perfect 0.975 on this chart. So then our z-score, or our z-critical value, is going to come from the chart. And if you can see here, the z that corresponds with this is 1.9. This would be 1.90, 1.91, 0.92, 1.93, 94, 95. This corresponds to a z-score of 1.96. So whenever I am told to use a 95% confidence level, the critical value z that I plug into my formula, which we will deal with tomorrow, is 1.96. This is what we're focusing on today. I give you the confidence level, we find the z-score. All right, so let's try another one. This time let's go 98. No, A, B. Need to know my letters. All right, 98% confidence level. All right, so what that's telling me is whatever my data is my lower bound and my upper bound are 98% of the data. So my tails then have to complete the 100. We know 98 plus 2 is 100. So if I cut my 2% in half, that means that each tail is 1%. So 98 plus the outsides have to equal 100. So I would take 98 from 100, that gives me 2, divide that by 2, gives it each a percent. All right, so for the chart, we only go from the upper bound down, so we include that left tail in the chart. So that tells me 98 plus 1, that together is 99%. So we're going to look for 0.99 on the chart. The closest thing to 0.990 or 0.99 as I can. So I'm going to pull out my chart. I'm looking for 0.99. And if you can see, there's lots of 0.99s, but we want to be as close to 0.990. And so we go here in this area. I got a 0.898 and a 0.9901. A perfect 0.99 would be somewhere in between those two. So we're just going to estimate and say in the middle. So this is 2.3. This is 2.30, 2.31. All right, so this is 2.32 and this is 2.33. So in between those, so this would be between 2.32 and 2.33. So we would actually, you can go even to the thousands. We would say 2.325 because that's 20 and that's 30. So then 25 is in the middle. So if you have one that's not an exact, but it's in between two, pretty much in the middle between two numbers, we can go right in the middle. If it's in between, but it's really leaning towards one, go with the one that it's leaning the most to. But in that last case, I mean, we were so close there. I'm going to say I've lost track of it. All right, here we go. That's only 2 10,000ths away, and that's only 1 1,000th away. Thousands are so close. I mean, 0.990 is maybe slightly over this way, but it's pretty much right in the middle. So we're going to use that and just go right in the middle, 2.325. All right, so I have a couple more of those. Let's do a 90% confidence level this next time. So that means that my upper and lower bound includes 90% of the data. So 90% confidence level means I'm in between. The whole entire curve has to add up to 100. So if this is 90, the outer two have to add up to 10 to make that 100. So that means each side is 5. So then for our chart, we include the left tail, not the right tail. So 5 plus 90 means I'm looking up 95% on the chart, or 0.95. Let's just stick with 0.95. They're 95%, but we're looking for proportions. They're never listed as percent. So we're going to try to find a perfect 0.95. Can we do it? All right, 0.95 would be, so we got a 0.9495 and a 0.505. 0.950 would be smack dab in the middle of those. They are the exact same distance apart. So we are going 1.6, and then we're in between 1.64 and 1.65. So we are going to go with 1.645. 1.645 would be the z-score there. Now the last one I want to do is an 88% confidence level. So that means we're talking middle of the range is 88. And so to find out the missing pieces, we subtract out that 88. That means the tails have to add up to 12. Divide that by 2. It means each side is 6. So this one is 6%. This one is 6%. We only want the left tail on the chart. Just remember, look at that picture. The left tail is the only one that's included. So we add those up. 86% or 6 plus 88 is 94%, so we are looking for a 0.94 on the chart. A perfect 0.94, don't know if we can do it. Oh, let's see. 93, oh, 94. Okay, that's more than 94. This one's less than 94. We are right in the middle there. My z-score is a 1.5, and it's in between 5 and 6. So 1.55, 1.56. So it's between 1.55 and 1.56, which, what's in between 50 and 60? 1.555. There we go. We've got our z-scores. Now, I will tell you, as far as memorizing these, you aren't required to memorize these, but I would definitely say 90 and 95 are the most used, so there's probably a good chance that you just, over time, you're just going to remember those. So I just wanted you to know that if you have some memorized, that's great, but probably 90 and 95 are the two that just over time you're just going to have them memorized because you're going to use them so often. So that's the first part of our lesson. So what we did here is we drew our curve and we labeled our confidence level. All right, so then we find the tails, and then you add the left tail for the chart. And then you use the chart to find your z-score. Or your z value. Sometimes you'll see score, sometimes you'll see value, it just depends. So I just wanted to go through that. Now we're going to do the reverse. So on the reverse, I give you the z-score, you tell me the confidence level. So we will do a couple of those. All right, so here we go. The very first z-score I want to give you. So we are going to find the confidence level given a z critical value. All right, so this time you will use the chart. That's one thing that's nice about it. But you have to do some work at the end. So this time I'm going to look at z equals 1.88. So what we're going to do is we're going to go to 1.88 on the chart. So we got 1.8 over here, 1 point, and then we go to 0.8 because that's the hundredths. Find out where those meet, and we get 9699. All right, 9699 is really close to 97. This one's pretty far away from 97. So 97 is definitely leaning towards there. So we can round. We're going to be easy. And we are going to say that this corresponds to the chart of 97%. Now, I want you to know that that is not the confidence level. And here's the reason why. If you remember from that picture, the confidence level includes the tail, or the chart includes the tail. Your confidence level does not. So let's just look at this. So the z-score 1.88 does correspond to 97% on the chart. But that means that the whole entire thing here is 97%. So just ask yourself, if this is all 97, what is this right tail? If all of this makes 100, this is 3%. So then remember, for your confidence level, you have a lower bound that matches because normal distributions are symmetric. So if this is a 3% tail, that means that there's a 3% tail over here that we really don't want. So the whole thing is 97, but we want to take out this 93, so that middle chunk is actually 94. And so this is actually a 94% confidence level. So whenever we were finding the z-value, we added the tail in before we looked at the chart. So then we're doing the reverse here. We find the percentage, but we have to subtract out the tail in order to get the confidence level. So we just have to remember the tails on each side have to match. So if this has a 3% tail, so does this one, and then just subtract it out. So that one gives us a confidence level of 94. All right, let's try another one. Let's go with a z-value of 2.325. 2.3 would be right here, and 2.3, 0, 1, 2, and 3. 2.325 is in between those two numbers, so between 2.325 is in between 20 and 30. So 2.32 is almost 99, but not quite. 2.33 is a little bit over 90, so right in the middle would be just 99. So that number on the chart corresponds to, from here down, is 99%. So that's telling me that I have a 1% tail here. I have to have a matching 1% tail over here. So if those two equal to 2%, that means that, or 99 minus 1 gives me a 98% chunk in the middle. So we're actually talking about that 98% confidence level. All right, I've got two more, and then I'm going to be done. All right, now on this next one, oh no, I got three more, sorry. All right, 1.08. 1.08. All right, so let's find that right on our chart. 1.0, 1, 2, 3, 4, 5, 6, 7, oh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 80.8599, really close to 86. That one goes a little bit beyond 86. So this is the closest to 86.0. So 1.08, we can rough estimate, say 86%. So from here down, the left tail included is 86%. So to complete that tail, this would be a 14%. So that means on this side, we have to have a match of 14%. So 86 minus that tail would give us what's left in the middle, which gives us a 72% confidence level. All right, so I don't know if you remember with z-scores, we like z-scores to be in between -3 and +3, just like we did on our charts yesterday. And so the closer they are to 3, the higher confidence we have. The closer they are to 0 or lower, the confidence level is going to go down. Now, I have one, and hopefully this is one that you're just going to remember, but I've got a 1.96. All right, this one is the most common. There's actually people in the stats world that like do Z races where they actually run 1.96 miles. All the AP readers actually do a run after they grade test. Super nerdy, but it is what it is. It's fun. So 95% is the most common confidence level, and the answer is 95%. But I just wanted you to see this one because this one is a perfect answer. So we did this the other way, but if you go to 1.9 over to 6, 1.96, that tells you 97.975 is that including the left tail. So that means here that the entire left tail and everything, all of that is 97.5%. So here, this is 2.5 to complete your 100. So that means that there's a matching 2.5 here. 97.5 minus 2.5 gives you a perfect 95% confidence level. So that middle percentage is what we will have. Now my last one is, and I'm going to just try to write it over here so I don't have to get out a new piece of paper or adjust the camera. Let's go with 1.285. All right, so the first thing we got to figure out is what the lower from that down to the left tail is. So 1.285, 1.2. Now 85 would be in between 1.28 and 1.29, so right in the middle there. If you can see, super close to 90. This one's just a little over 90. So right in the middle, we can assume that that's an even 90%. So this is 90%. So then that means that we have a tail of 8, or a tail of 10. Means we have a matching tail because of symmetry of 10 here. So then we just have to find out if these add up to 20, the middle adjust. Oh my gosh, don't look at that picture, that's awful. The middle chunk would be an 80% confidence level. So tomorrow we will be dealing with, we'll be calculating how far. Now I just want, or how to calculate the upper and lower bounds of a confidence level. But I just want to show you something and you can tell me what this means. All right, so we were talking about like the bigger z-scores earlier. The bigger the z-scores, the bigger the confidence levels, and when they went lower, the confidence level got lower. So what this means is when you have a bigger confidence level, it actually gives you a larger margin of error. It allows you to make more mistakes. And I just want to ask you this. If we had bullseyes, so we're playing darts. I have 2 targets. I have target 1 and I have target 2. Which one would you have more confidence of hitting and why? And I would hope that you would tell me that you have more confidence of hitting target 2 because you have a better chance of hitting it because there's more area. So there's more area because, and you're going to have a better chance of hitting this target just because you have more room for error. This one, it's almost like you have to be so accurate to get an answer. But if I were to go through this, I could say like, oh, I'm probably going to hit this target 50% of the time, but this one I'm probably going to hit 80% of the time. And so on this one, it gives you a bigger range because you have more confidence. More confidence because of the bigger range. And I just want to clarify that because we will be dealing a lot with confidence levels and it just gives you a better chance of hitting those targets. So I am going to stop for today. If you have questions about any of this or any of the Khan Academy assignments, make sure you email me. I am available. I am staying at tomorrow or Thursday. I am here till 4. Friday I'm here until 3:15ish. So if you need me, just send me an email and I will get back to you. If we need to do Google Meet or whatever you need, just let me know. I will see you all soon and have a great afternoon.